Okay, the next part is about the area. This is the application of integration. Okay, what is area? Area means that area under the curve. For example, let's say we have this area A. We have this function. You can see in page 11. Uh, in other words, we can say this area for positive curve, that curve above the x-axis. Curve above the x-axis, see the horizontal line. This x-axis, curve above the x-axis, and this x-axis and y-axis. Okay, for this curve, the area, the A area, the area of A that is between x equal A until x equal B. From x equal A until x equal B, this area or this shaded area is also equal to the indefinite integral. In the indefinite integral for fx between x equal A until x equal B. That's why the uh, definite integral is very important. That will help you. We can apply that concept uh, to find the area under the curve, area between the under the curve, below the y, the function, and above the x-axis in interval x until a x equal A until x equal B. Okay, that is the concept. So the area of A, for this case, the area of A, this also equal to the definite integral of fx dx from A, from x equal A until x equal B. The area must be the area is below the y function and above the x-axis. That's we call it as a positive area. Okay. Meanwhile, for the negative function, that the area is below the x function, as you can see in this page. For this function, this area is the area of A is below the x function. This area is also known as the negative function. Okay, this area is equal to the negative definite integral of fx dx until x equal A until from x equal A until x equal B. Okay, that is the how we can apply the dy. Sorry, not dy. The definite integral. That's why at the end we will get the number for definite integral, because the number is also can be referred as the area or the shaded area under the curve. And then situation number 3 is area between curve. Area between curve. This area, uh, for example, is area between uh, y equal to gx, and this one is y equal to fx, between fx and gx. Okay, this area between the area of A, the shaded area between fx and gx. Okay, this graph basically show that the area between these two curves, there is between fx and gx over the interval x A and B, from x equal A until x equal B. Okay, this area, okay, what we call it, the shaded area that is marked as A, is lie between these two curve from x equal A until x equal B, as I explained earlier. Okay, in order to find this area, okay, in order to find this area, we can apply the definite integral. But how to find this area? First, between this integral of between the respective area, this shaded area A, first we need to identify the curve, what we call it as a, you can see here, this area. First, we need to identify the shaded area. Okay, we need to identify the upper curve, the function that that form the upper border or upper boundaries of this area. When we move from A to B, we can see here uh, the upper what we call it, the upper area, hat atas, this area. This upper area of this curve is belong to fx. And then the lower curve, the lower area, the lower boundaries of this curve, as you can see, the red one is belong to the gx. So in order to find this area, we need to identify the curve, which curve form the upper boundaries, and then which curve form the lowest boundary. From A to B, we can see here the upper boundary is belong to fx. The lower boundaries is the lower area of the area is belong to the gx. So in order to find the area, the A area, the area of A, we can calculate the first. We can calculate the definite integral between x equal A until B, and then we take the difference between the fx minus gx. Okay, that is the formula. Why fx minus gx? Because fx fx form the upper area of the curve, the boundaries, the upper boundary of the curve is belong to fx, and then the gx, the red line is belong to the gx. Another cut between A and FB, between x equal A until x equal B, fx is greater than gx. The value of fx is greater than gx throughout the interval. So the difference between this fx and gx give the vertical distance between these two functions at each point of x. And then when we take the first integral, we take the definite integral, that will give us the total area. Okay, so that is the formula when we want to find the area between the curve. Okay, there is three situations here. The first one, when the area is above the x-axis. Then the second one, when the area is below the x-axis, we need to take the negative definite integral. Or the situation number 3 is area between curve. Okay, let's look for one example here. Okay, let's say I have this example, this quadratic example, y equal to negative x squared. Y equal to negative x squared. Okay, when we upload this area, this is a quadratic. Okay, now let's say the question is, we determine the area between the x-axis and the curve y equal to 16 minus x squared. That is the area A. What is A? Find A. For example, find A. What is the total area of A? Okay, so in this case, we only have one function, y equal to 16 minus x squared. Then in order to find the area, we need to find we need to take to calculate the definite integral between these two interval, there is -4 and 4, or -4 until 4 dx. And then since the area is above the x-axis, uh, uh, we can just find the area by using the definite integral. Don't need to times -1. So based on this example, as you can see here, I will show you the step by step. Okay, as you can see, there is uh, the work how to find the area. I will show you one by one. Okay, the next one, we just take the first derivative. There is 16x minus x to the power of 3 divided by 3 from -4 to 4. Okay, that is the first step. The second step, we just substitute x equal 4 into the equation. Is 16 times 4 minus 4 to the power of 3 divided by 3. This is the first part. The first part. And then the second part, we take minus. Now substitute x equal -4 in the equation. Minus 16 times -4 divided by -4 to the power of 3 divided by 3. And then we just take the difference. You can see the answer is 85.33 units. You can add the unit that is there for the total area. Okay, that's how to apply the definite integral in order to find the how to apply the indefinite integral in order to find the total area. This is quite easy here because they straightforward. We just apply the definite integral. Okay, the next one, how to find this area. How to find this area? Okay, I will show you the step one by one because there are two areas here. Let's see. We have these two functions. Okay. Yeah, let's see. We have these two functions. Okay, so calculate the area between y equal 4 minus 2x, and then an x-axis in this interval -1 and -1 and 3. As you can see here in this graph, we have this area. The first area, let's say from, okay, what is this function is y equal to 4 minus, okay, this y equal to 4 minus 2x. Okay, we know this is a 4. This is a c. This is a linear function. And then this also the 2 when x equal 2. Okay, when we move from x equal 1 until x equal -3, basically there are two areas, area A and area B. Okay, for area A, the area A is above the x-axis. The area B is below the x-axis. So if you find, let's say, but be careful here because we have these two. We have these two different area. We have two different area. Okay, the first area is A. The area of A is above x-axis. The area of B is below the x-axis. If you find the area by using this equation, okay, let's say you find the definite integral of 4 minus 2x dx from x equal -1 until x equal to 3, that is wrong. It's not correct. First, we need to identify the area, the actual area. You need to determine whether all the area is above x-axis or below the x-axis. For this case, we have two areas. Area A above the x-axis, area B is below the x-axis. Okay, for area A, since the area of A is above the x-axis, between x equal -1 until x equal 2. We can find the uh, definite integral straightforward. 4 minus 2x dx. We get E. But for B, for area of B, since the area of B is below the area of B is below the x-axis. Okay, we still we can apply the same formula, but make sure, but since the area is below the uh, below the below the x-axis, but we can still find the answer by using the definite integral between x equal to x equal to until x equal 3 for the function, the same equation 2x dx. But please remember that the area of B is below the x-axis. That's why the definite integral we must add a negative in front of the negative integral, because in order to make the answer, to make sure the answer is remain positive. So for this area, we can find one by one. We can find this area one by one. For area A, there is the definite integral 4x minus 2x squared divided by x until from x equal -1 until x equal +2. Okay, now this is equal to 4x minus x squared -1 until 2. So this equal to 4 times 2 minus 2 squared minus, now substitute x equal -1 in the equation, minus negative, sorry, this is a negative, be careful, double negative here, negative x squared. Okay, you can get for A area, the answer is 9. This for A area only, the answer is 9. But for B, again, the same process here for B, but remember B has a negative sign here. There is a negative 4x minus 2x squared divided by 2 from x equal 2 until x equal 3. So there is a negative uh, negative there is a negative 4x minus x squared 2 to the power 2 and 3. So there is a negative 4 times 3 minus 3 squared minus uh, 4 times 2 minus 2 squared. You will get the answer is negative. The answer is positive because this is a negative time negative. Negative, this is a -1, I think so. So the answer is 1. So for the area B, the area of B, the answer is 1. The area of A is 9. So the total area A plus B equal to 9 plus 1. The answer is 10. 10 unit. 10 unit. Okay, that is the area, the total area of A. Just for this example, just want to show you that be careful when you want to calculate the total area. Make sure you need to make sure you need to determine whether all the area is above the x-axis or below the x-axis. So that's a very important. Otherwise, you will get the wrong answer. That's for the area of A and area of B. Okay, that is the concept for integration. In other words, I can say here, we can conclude here that integration is for total area. We can apply the integration in order to find the total area. For topic 6, differentiation is more on the or divide the is more on the slope, the slope of the uh, the slope of the tangent line. Okay, that's the concept for the difference between topic 6 and topic 7. The difference between the integration and also the differentiation. Okay. That's there is another example. I hope you can review by yourself another example, and then if you have any question, you can ask me, or you can ask me by WhatsApp, or you can we can discuss about it in my office. Okay, there's another example. Okay, the last one is about the application for today. How to apply? This is very important part. Every topic has this, has the as this section, the application of the topic. We have the application of limit and continuity, the application of linear, quadratic, the application of uh, differentiation and so on, because it's very important because it's for uh, for this topic, for this course, there are two major part here. You need to know the theoretical part and also the application part. The application part will be applied more on the economic and business. Okay. Okay, the first part. Okay, now I will explain about the how to apply the integration in term of revenue and cost. Again, in term of revenue and cost, we have total cost, uh, total revenue, uh, and then we have marginal revenue and marginal cost. Okay, again, as so in other words, there is a close relationship uh, between topic 6 and topic 7 in term of application. Okay, the first one, I will show you the relationship between total cost and total revenue. Okay, again, what is total revenue? Still apply the same concept of total revenue and total cost. We have a total cost here. Let's say total revenue. Or TR. In economic, TR equal to P times Q. Number of output, the price of good times quantity. That is total revenue. Okay. And then from total revenue, okay, from total revenue, in topic 6, in topic 6, the first derivative, TTR, DQ, equal to marginal revenue, MR. It's a marginal revenue. Okay, that is a DTR, DTR, DQ. That is a total revenue. So if you have MR, so in other words, we can say that MR is the first derivative of TR. And then TR is also the antiderivative of MR. So the first, in other words, the integral of the integral of MR dq is also equal to TR. Okay, that is the relationship between the MR and TR. From TR, the first derivative of TR is MR. The integral of MR is equal to TR, total revenue and marginal revenue. Same goes to the total cost. We have a total cost or TC. Total cost or TC. The first derivative of TC, dTC dQ, equal to MC. MC is marginal cost. MC is marginal cost. dTC divided by dQ is MC. So MC is we can say that MC is first derivative of dTC. Then in terms of integration, we can say that dTC is anti-derivative of MC. So the integral of MC, antiderivative dq equal to TC. But for this case, because now I'm talking about the indefinite integral, TC, we have the indefinite integral. We have to put plus C. For MC, no, if we refer to lecture note, I put here the C is now equal to the fixed cost in this concept. Is TC plus C, and then C here is a fixed cost. But for TR, there is no TC. There is no TC. TC is 0. There is no need to put TC, because in economics, when Q equals 0, TR also equal 0. So there is no in TC, in total revenue, the first in total revenue, when we want to apply the first when we want to apply the derivative or the integration, no need to put plus C, because since Q in economy, when Q equals 0, TR is also equal 0. But for marginal cost, since we have the concept of fixed cost, the size of C will represent the fixed cost. That's why, please, in this case, you need to differentiate between the function, the linear function in general, quadratic function in general, or whether the function is whether the function is what we call it total revenue or total cost. Same goes to if when we're talking about the demand and supply. Okay. For example, let's say I have this function. For example, I have the MC, marginal cost equal to 5q squared plus 7. Okay. Find total cost if fixed cost equal RM 200. Okay, find total cost if fixed cost equal to 200. Given in the question, is MC. In order to find TC is integral of MC dq. So this is equal to integral of 5q squared plus 7. So 5q squared plus 7, and then dq, the answer is 5q 3 to the power of 3 plus 7q plus C. So plus C. So because this is a total cost function, C is a fixed cost. in the question, fixed cost is 200. So the correct answer is TC equal to 5 over 3Q to the power of 3 plus 7Q plus 200. Okay, that is the final answer. Now, in this that means we need we need to what we call it, to modify between the integration and also the total cost function, because in general total cost, based on the economic theory, the total cost can be divided into the fixed cost and variable cost. For this total cost, for the example, okay, this first part is a variable cost, the last part is a fixed cost. That's how to apply the total cost in terms of integration. Okay, that's the first example for application. The next one is about, let's say, for total revenue and total cost. Given MR equal to, given marginal revenue equal to 10 minus 2Q minus 3Q squared. This is a marginal revenue. Find, determine total revenue function. Yeah. So given the question is MR, so TR equal to integration of MR dq. It is equal to integration of 10 minus 2Q minus 3Q squared. So the answer is 10Q minus 2Q to the power of 2 divided by 2 minus 3Q to the power of 3 divided by 3, and then plus C, based on the because this is a indefinite integration. So we can simplify this. The answer is 10Q minus Q squared minus Q to the power of 3, and then no need plus C. No need plus C, because for TR, when Q equal 0, TR must equal 0. That is based on the theory. So in terms of total revenue, it's no need that there is the constant is not relevant in this question. But for total cost, the constant is relevant because we have a concept of fixed cost. And then please remember when we apply this concept. Okay, that's about the total revenue and total cost. Okay, the last one for today is about the okay, this is very important. I hope you can pay your attention, because this part is very popular. If you refer to the previous semester, every semester there must be a question come from this consumer surplus and producer surplus. I hope for this semester you can answer, all my students can answer this question. This question is compulsory. Every semester there must be at least one question from this topic. Okay, the topic is about the consumer surplus and producer surplus, lebihan pengguna and lebihan pengeluar. In bahasa Melayu we call it as lebihan pengguna, consumer surplus, lebihan pengguna, and lebihan producer surplus, lebihan pengeluar. Consumer. Okay, in general, the consumer surplus, when we're talking about the consumer surplus, is the total gain to consumer who are willing to pay more than the equilibrium price. If you refer to the demand and supply, again, there is a demand and supply curve. I have explained more on this more than I explained this more. Explain more about the demand and supply, especially in topic 1, because this is very important. There is the basic theory in economics. So when we have supply and curve, the intersection between supply and curve is known as a equilibrium point. Let's say we assume that at this point, this is also the market price. The consumer willing to pay this PE, this equivalent, and producer is willing to receive this amount of this price level. Okay. So in other words, we can define the supply, the consumer surplus, as a difference between what consumer are willing to pay, apa yang dia sanggup bayar, and the price that they are actual pay for the quantity of a good purchase. Perbezaan antara harga yang disanggup bayar dengan harga yang sebenarnya bayar. That is the consumer surplus. In terms of graph, when we look into the graph, this consumer surplus or CS is the difference between the willingness to pay for a good and the price consumer. Each price along a demand curve, let's say for any price that is on this curve, represent the consumer marginal benefit for each unit of compensation. Okay. But the actual the price is the price along the curve is also represented the price that consumer willing to pay. But the actual price paid by the consumer is PE. PE is also known as a equilibrium price or market price, for example. Market price. So for each quantity that consumer pay, there are different. There must be a gap between the what we call it, the price that consumer willing to pay and the price that the consumer actual that consumer have to pay. So the total difference between these two price, we call it as the consumer surplus. Okay. In the graph, the consumer surplus is showed by this shaded blue area, this blue area or CS. That is consumer surplus. Consumer surplus. Okay, there is a consumer surplus or CS. Okay, this one. Consumer surplus. Meanwhile, for producer surplus, for producer, the producer surplus is can be referred to the total gain to the producer who are willing to supply lower than the equilibrium price. Or in other words, there is the difference between the price that a seller receive and the price that the seller willingness to sell for each quantity. Okay, the price along the supply curve. Okay, there's a supply curve. The price along the supply curve is represent the price that the seller willing to receive. And then the PE, there is the actual price that the seller receive from the market. When we move from the left to right until the equilibrium quantity, the difference between the actual price received by the seller and the price that seller willing to receive, we call it the area is a producer surplus. There's a producer surplus. There's a producer surplus. So the red area, the red dot area is the producer surplus. The blue area, the blue shaded area is a consumer surplus. So how to find this area? Okay, basically in this class, you need to find this area by using this formula. This formula is related to the definite integral. If willing to the refer to the definite integral. Okay, this formula you need to know how to apply this formula. Basically, the formula is given in the final. You need to know how to apply this formula. That's why I hope all students can answer this question. Normally the question about the consumer supply is and producer supply is a popular question. The question is all I think every semester there must be at least one question related to the consumer supply or producer supply or both. Sometimes you need to find consumer supply and also the producer supply. Okay, that is the concept of the consumer surplus and the producer surplus. Again, what we call in conclusion, we can say that the difference between a consumer marginal benefit for a unit compensation, that is what they actually pay and how much and will represent how much benefit a customer get from the price that are paying. But for seller, we can conclude that the difference between what the price that the seller for each unit and what is the cost for the seller to produce the last unit represent the seller benefit from the price they are getting. And that in economic we have these two type of people, these two type of good, the consumer and also the seller. The benefit for consumer is represented by the consumer surplus. The benefit for producer is represented by the consumer producer surplus. But now, how to calculate? Okay, how to calculate the producer and consumer surplus? Okay, as you see, you can if you refer to the page 19, 11, 19, 20, and 21. There's a few examples. Okay, I will choose one example. For example, okay, I will explain this. Let's say this graph. Please refer to page 90. The full question is from the page 90. I just want to focus on this graph in order to find how I want to show you how to find the answer. And then the full question and the full answer you can refer to my lecture note. Let's say that I have this graph. Okay. So given there are two demand and supply curve, there are two demand. This of course a demand. This is a demand function. So the slope is negative. Oh, sorry, this is a supply function. Oops. It's supply. The red line is a supply. The blue line is belong to the demand. Now, given there is a equilibrium price and equilibrium quantity, QP and QE. The intersection between demand and supply is referred to the equilibrium quantity. But the question is, we want to find the consumer surplus, this area, and producer surplus, the area, CS and PS. Okay, how to find the area? Okay, for consumer surplus, CS. Okay, the formula is there is the integration of the demand. What is the demand function? The demand is the definite integral of the demand 100 minus 0.5 q squared dq from q0 until qe. Q0 until QE. That's the formula for the consumer surplus. Okay, you can refer to page 20. The full answer is in the page 20. Okay, now and then this part must be, because we want to know the we just want our focus now is on the blue area on between the area between the demand curve and the price line. We are not going to find the total area below the demand curve. We just want to find the area between the demand curve and the PE and the equilibrium price. So that's why we need to minus PE QE. That is 87.5 times QE5. Okay, that is the formula. This belong to PEQE. Okay, in other words, we need to modify the formula for the formula of definite integration, because CS is the area for CS is only between the price line and the demand curve. We are not interested in to find the total area under the demand curve. We just want to find the part of that area for CS. Okay, so based on the indefinite integral, is equal to you can refer to the formula of integration. This equal to 100 q minus 0.5 q squared. That is a 0.5 q to the power of 3 divided by 3 from 0 to 5 minus PE times QE. Okay, until this is equal to 437 point 0.5 437 0.5. So based on this integration, definite integral, okay, this is 100 times 5 minus 0.5 times 5 to the power of 3 divided by 3, and then minus I think minus 0. Okay, minus 0, because when q equals 0, the whole question will equal 0, and then the last one minus 437.5. So the total for consumer surplus is RM 41 ringgit 67 cent. That is for the total area of CS, or the value of consumer surplus. This one. Okay, this one, the area is RM. The total consumer surplus is RM 41 ringgit and 67 cent. Okay, by using the same concept, we can find the PS. We can find the PS. Again, the PS is an area between the price line and the supply curve. We are not interested to find the area below the curve, but we can. Our focus is only on the area between the price line and the supply curve. So that's why, based on the indefinite integral, the formula is for producer surplus. I hope you can remember this formula. Kalau ingat lagi bagus. The first part is we need to find the product of P and Q. P and Q. P and Q. In this case, PE and QE minus the definite integral between Q0 and QE for the what we call it for supply curve. What is formula for supply curve? For supply curve as SQ DQ. That is the general formula for supply curve. So PEQE again, this is equal to 187.5 times 5 minus the first the definite integral between 0 and QE. QE is 5 for demand. For supply. Supply is 50 plus 1.5 Q dQ. Okay. So now we can solve this equation. It is 437 and 5 minus, okay, this part is the definite integral, 50 Q minus 1.5 Q2 to the power of 2 from Q0 until Q5. That is the definite integral. Okay, the next is we just solve this question. 437.50 minus. First, we just substitute. Substitute Q equal 5 in this question. 50 times 5 plus 1.5 times 5 to the power of 2 times 2. That's the first part. The second part is 0 because this 50 times 0, Q equals 0 plus 1.5, 0 to the power of 2 divided by 2. The answer is 0. Okay, that's why the total answer, the answer is we just 437.5 minus this 312.5 0.5 and then minus this minus 0. Then the answer is RM 100 and 125. Okay, that is for what we call it for this number is will represent the producer surplus PS. That's the value of the producer surplus. For this case, the area between the price line, the equilibrium price, and also between the area between the price and also the demand, and also between the price and supply curve. That's the value. The value of PS is 100 and 135. Okay, that's all. How to find the total area. How to apply the concept of total area under the curve to find the consumer surplus or producer surplus. Okay, that's in conclusion. I can say here, I can conclude here that for this topic, the integration topic is related to the what we call it as this topic is related to the this integration topic is related to the total area under the curve. Then with the application on the consumer surplus and producer, and also producer surplus. Meanwhile, for topic 6, the differentiation of focus is more on the slope of the tangent line. And then, by the way, at the same time, there is a relationship between the total revenue and total cost, total revenue and marginal revenue, total cost and marginal cost. The first derivative of TR is MR. The first derivative of total revenue is marginal revenue. And the integration of marginal revenue is equal to the total revenue. Same goes to the total cost and marginal cost. The first derivative of total cost is marginal cost. The integration of marginal cost is equal to the total cost. So that's the I hope you can see the connection between the topic 6, especially between topic 6 and topic 7. Okay, I think that's all for today and also for our class for this semester. Any question? For the other example, I hope you can review by yourself. Please refer to my lecture note and also all the video and other lecture material that I share with in the UKM folio. Okay, and any question? I think that's all for today.
Doctor.
Okay, if you have no question, I think that's all for today. Thank you for your thank you to all students who attend my class today. Again, I apologize about our class. Supposedly, our class today is must be in face to face because I think since the second part of this semester, since 8, it's not mistaken, 8 or 9. Our class is online. But now, unfortunately, due to the some situation I cannot avoid, I have to change the face-to-face class to online class today. But I think if you have any question, you want to ask me any question, you can ask me to via WhatsApp, or we can set appointment and then we can discuss about it in my office. And then I think that's all for my for today. Good luck for your final exam, and then I will share with you all the all your mark, your KI mark, and then I also will share with you how to calculate your KI mark. I hope that's all for today. And then for your attendance, as usual, your attendance will be recorded automatically by Tin. By Tin, please wait until I end this meeting, uh, uh, in order to make sure that your attendance is recorded properly. Okay, that's all for today. Okay. If you have okay, that's all for today. Okay. And good luck for your final exam.
Hello, Professor.
Yes. Any question?
I'd like to ask our quiz.
Okay.
Today quiz.
Okay, yes, of course. We are supposed to have one quiz today, but the quiz must be in the class for physical class. But unfortunately, uh, our today class is not a physical, and then it's okay. The quiz now I will convert the mark for quiz to the attendant, and then for students who attend my class today, I will give bonus 5 mark lah to replace your quiz number 2. I think so far we only done one quiz, right?
Yes.
Okay, and for quiz number 2, I will the quiz will be based on your attendance. If you attend my class, I will give you 5 marks, and then I will produce your marks in you can follow later. I will make an announcement about it later in you can follow.
Okay, thank you.
Okay, any other question?
Doctor,
Yes.
if I missed the class on Friday because I have another class, I contact you on the WhatsApp. How to calculate the attendance?
Okay. I think for our class on Friday is for replacement class. Okay. If you have another class that has been scheduled earlier, you just let me know. What is the class? Sir, I cannot attend your replacement class. This is my class. You just share with me your class course code, and then your lecture name, and also show me your proof that you attend the class, and then I will I will exclude you from the attendance record for that day. But for today, there is a scheduled class for our class. Just I think in other words, all students must attend for today's class. Okay.
Thank you,
Okay.
Doctor.
Okay. Okay, if there is no question, that's all for today. Okay, see you again, and good luck for your final exam.
Thank you, Doctor.
Okay, welcome.
Thank you,